Uh, yeah, good morning. Sorry. Hello, good morning. Am I audible? One second. Hello. Can somebody speak out? Hello. Oh, at last I could able to share my camera. Oh, sorry so much. Good morning, all of you. Can somebody unmute? Ayush? Hello, Ayush.
Yes, sir.
Yeah. Sorry for the technical glitches. I was unable to show my camera input. Fine. This is what we discussed in the last class. Let us just make a review of the things what we learned in the last class. So we were discussing how to develop a wave shaping circuit. So we thought of having some waveform which is slightly different from a sine waveform. So we thought of analyzing the circuit. So we started with very simple circuit having a diode and the resistor. So of course we know that a diode can be ideally thought of like a switch, so it can be closed or open depending on whether it is forward bias or reverse bias. Of course we say that a diode will be forward biased if the voltage at the anode is greater than voltage at the cathode. That is, voltage at the p type should be more than the voltage at the n type. So this is a condition, we call it as the forward bias condition, where we will going to represent the diode by short circuit. So on the other hand, if the anode voltage is less than the cathode voltage, we call it as reverse bias. So in an ideal condition, I will treat it as an open circuit with a reverse resistance of infinite ohms. So you represent the same diode with an open circuit. So that's what we wrote here. For each and every circuit, before we start writing the expected output, so you better write what is the equivalent circuit of the given circuit when the diode is on and the diode is off. So once you are done with the two circuits corresponding to diode on diode off, then you try to write the output expression. What is V naught? Now in this case, since it is connected here, V naught is equal to V in. In this case, output is connected to ground when there is no current flowing when the diode is off, so output is 0. So we have first phase where you are writing the equivalent circuit when diode is on, diode is off, and then you are writing what is the output voltage expression under those two conditions. And then the last and the most important one, so we need to find out when does this is possible, when does this is possible. So of course, since we know that voltage at the cathode is at 0, any voltages above 0, this is the valid circuit. This is the valid circuit when the input voltage is less than 0. Then we could able to write this. Is that fine?
Yes, sir.
Yeah. Is there anybody in the class now, around 40 to 43 students? Do you have any issues over here so far? Because this is one of the simplest. Of course, we tried with this, then we tried with the other two circuit where we didn't have too much complexity in terms of waveforms. So, sorry, in terms of circuit diagram. Is that fine? Okay, this was our first circuit. Then we just started with the second circuit where we had something like this over here. So we could able to again write the equivalent circuits and then the expression for V naught, and then when does that will happen. So when does the diode is on, diode is off, and the corresponding output voltage. We repeated the same thing for other two circuits. It is this circuit for a diode is placed here, and then this is the when diode is on, diode is off. Next the question is when it is on, when it is off, and what are the corresponding output voltages. Can I just know from each one of you, is this okay till this point? So just okay, if you have any questions, so let me know so that I can solve it out and then proceed to next circuit. And of course we also saw that something like this where the diode is off all the time. The diode is off all the time, whether it is positive half or negative half. So output voltage is equal to input in this particular case. Quickly just give your thoughts of these 5 circuits. Is it fine or not? Of course, I think we discussed this also. And then I said, I think I gave this as an assignment. Can somebody able to solve this?
Yes, sir.
Yeah. So can somebody able to share your screen so that I can able to, or you can just put it across in my WhatsApp message so that we can able to.
Yes, I'll just complete.
Are you sharing here? What are you doing now? Okay, what we'll do is, instead of just looking at your things, so let me start with the analysis of that particular circuit. So benefit of time constraints. I hope my recording is going on. Let me just check it once. Yesterday somehow I could not do it properly. Now I think recording is going on fine. Okay, now this is. So we always consider the input is a sine wave like thing. This is R. Let me say it as this is 2 volt and this is diode. We are always considering the diode to be an ideal one. So this is V in, this is V naught, and this is ground. Can we write the equivalent circuit? Okay, what is the equivalent circuit when diode is on? How do I replace diode by what? Ayush? Diode is replaced by what when it is on? A short circuit. Hello? Can somebody just unmute so that I can able to feel that I'm there?
A short circuit, sir.
Okay, what are the corresponding output now? Can you say what is the output? This is when D is on.
So when D is on, it will be minus 2 volt.
Perfect. This is minus 2 volt. Then when the D is off,
V in.
so V naught is equal to V in. So this is where you're measuring V naught. This is equal to V in. Next the question is, Okay, this is D is off. Correct. The question is, when does the diode turns off? So what is the voltage at the cathode? Voltage at the cathode is how much? -2 volt. Am I correct?
-2 volt.
For what voltage of V anode? For what voltage of V anode? This will be on. The diode will be on, because we know that V anode should be greater than V cathode for it to be turned on. Correct?
Yes, sir.
For what all voltages this will turn on?
Above -2.
What do you mean by above -2? Is it -1 -2.1 above -2?
No, sir. 1.9 and
Like
minus
-1.9. So if I want to write a waveform something like this here, suppose if I write this is my dotted line, this is my dotted line, the input voltage. Shall I write -1.2 as my reference? Sorry, -2 volt. This is -2. Correct? Am I correct? -2
Yes,
volt.
sir.
Sorry. Let me just show it. This is -2 volt. It is no, somehow not writing it there. Okay, this is -2 volt. So is this value below this? What are the condition of your diode? Anything below this?
The short circuit.
Anything below this? Anything, you can see the input is going here. The input is actually going here. If the voltage is lesser than -2, like -2.1, -2.2, what will be the condition of your diode? Here,
So it will be off.
it will be off. Am I correct? Over here,
Yes, sir.
it's on.
On.
Correct. So, shall I say now? During this region, is the input voltage. Let me just write it over here. So, till this point. During this region, E is the diode on or off? See here, this input voltage is more than this. Is the diode on?
Sir, on, sir.
Here? Oh, sorry. Now, please just remind me if it is not visible. Say that, sir, it's not visible, because I'll be looking at this. I may not look at the screen. Is this off here?
Yes, sir.
Is this on here? Just a minute.
Yes, sir.
Just a minute. Let me just complete this to come down here. Is it till here? Correct?
Yes, sir.
Okay. When it is on, what are the voltage?
-2 volt.
-2. Is it now -2 volt here? Correct?
Yes, sir.
Then when it is off,
It will follow the path V in.
will it follow?
Yes.
How about this?
-2 volt.
Is it something like this?
Yes.
Do we get a waveform? Suppose if I rewrite this, one for till -2 volt, is it something like this? Correct?
Yes, sir.
This is -2 volt, this is T. Fine?
Yes, sir.
Okay. We'll move on to next one. Please stop me if any one of you are not getting anything anywhere. Let me write this circuit. So shall we write the equivalent circuits? First and foremost thing,
Yes, sir.
with short circuit, how it looks. Correct?
Yes, sir.
Correct?
Yes, sir.
What is the output now? What are the output here now? Okay. Before you know the output, shall I write it as 2 volt here, or let me write as V reference? Plus minus, this is plus minus, this is minus plus. Am I correct?
Yes, sir.
Now, can I write the KVL now? V in is equal to, suppose if you write the loop, V in is equal to V reference plus V naught.
Yes, sir.
What is V naught then? Is it not V in minus V reference? Or is
Yes.
it now V in minus 2 volt because your V reference is 2? Correct?
Yes.
How about V naught here?
So it is minus 2 volt.
Here. What is the drop? What is the current?
So 0.
What is this? What, V naught is nothing but this voltage drop, no? When current is, what is I into R?
So the voltage at is 0.
Voltage across resistor is 0. So it is 0 volt.
Yes, sir.
Correct? This is when D is on, this is when D is off. Correct?
Yes, sir.
So now, what is the voltage at cathode? Is it not 2 volt?
Yes, sir.
When does this diode will turn on D?
So
When,
when anode
2 volts, sir.
is greater than 2 volt.
when the anode voltage is more than 2 volts.
Yes, sir.
Correct? Shall we write the waveform? Is this fine? Shall I write this as
Yes,
2
sir.
volt line? Correct?
Yes, sir.
Any voltage above 2 is the diode on.
Yes, sir.
Any voltage below 2 is the diode off.
Yes, sir.
Correct? Now, this is a transition point where it is going above 2? Hello?
Yes, sir.
Is this is again one more transition where the input is going below 2? You just see, okay,
Yes, sir.
you just drop a line wherever there is a transition happening from input and the reference line. Correct?
Yes, sir. It will be off.
Okay, now is this off here? Is this on? Okay, let me write it using some other pen. This is on, this is again off, this is on, this is off. Correct?
Yes, sir.
What is when it is on?
So V in minus 2
Okay,
volt.
before that, when it is off, what is the voltage? Because it is off initially,
0.
it is 0. Is it correct?
0. Yes, sir.
Shall I write 0 here for again off?
Yes, sir.
Shall I write 0 here? Assume that of course, what is the input voltage here? Is the input voltage 2 here at this point?
Yes, sir. 2 volt.
When the diode turns on, what is the output voltage?
So 0.
Input minus 2, input is 2, minus 2 will become 0. Correct?
Yes. Yes, sir.
If the input is 4 volt, what is the output?
So 2.
If the input is 10, what is the output?
8.
So
8 volt.
will it be a same sinusoidal waveform with some amplitude
2
minus 2
volt
volt?
down.
Can you see it is down
Yes.
by 2 volt at each and every point? This is the down 2 volt. This
Yes, sir.
separation is always 2 volt. Why it is 2 volt is because it is lesser than 2 volt. At each and every point, this voltage is lesser than 2. This voltage is lesser than 2. Correct?
Yes, sir.
Will it follow exactly the same thing here? Of course, not to the exactly the scale. This is how we'll get it.
Yes, sir.
Correct?
2 volt down.
2 volt down whenever the diode is on. 2 volt down compared to the input voltage.
Yes,
Done?
sir.
Done? Is that fine?
Yes, sir.
Okay. Now what we'll do, I'll slightly modify the circuit. Again, it's the same diode direction. Let me is this fine?
Yes, sir.
Can you write the equivalent circuit?
So we can say directly, sir, it will rise above V in 2 volt.
Perfect, perfect. That's what I want. So maybe since it is the initial classes, I'm just writing it so that you need not panic. That's perfect. So that's what I ultimately want. If you're writing it like this, okay, it will be okay. It will be easy for all of you. So when D is on, what is V naught? V in plus 2.
So V in 2 volt.
Plus 2, correct? When D is
Yes,
off,
sir. 0.
V naught is 0. Perfect. Because since we discussed this one, we can easily write it. Suppose if you are writing for the first time, then it is better you write it like this. Got it?
Yes, sir.
Yeah, fine. So you just make a practice to just write equivalent circuit so that it will be easy for you. Otherwise, you'll be in panic. Okay, let me rewrite that. Next, the question is when it will turn on, when it will turn off. Correct? So
Yes, sir.
what is the voltage at V cathode? Is it minus 2 volt?
Yes, sir. Minus 2 volt.
What will be the voltage at V anode to make it turn on?
So it should be greater than minus 2 volts.
Like minus 1.9, minus 1, minus, correct?
Yes, sir.
Okay, let me just, can I write it as minus 2 volt here?
Yes, sir.
Is this 0 volt more than minus 2?
Yes, sir.
So shall I mark this demarcation line wherever it is crossing it?
Yes, sir.
So during this region, what is the condition of your diode?
Sir, off.
Here, input is more than minus 2.
Sir, on. Sir, on.
Correct?
Yes, sir.
Here,
Off.
because you have to always see the input is going to anode. If the anode voltage is more than minus 2, it's on. Now this is the anode
Yes, sir. It
voltage
is
which is less
less
than
than.
minus 2, it is off. Correct?
Yes.
This is on now. Now when it is off, what is the voltage?
0 volt.
0. So shall I write that 0 here? Correct?
Yes, sir.
Now here, because this is off here, this is again off here. When it is off, okay, what are the voltage at this point now? Okay, now how it will go now? So now this is minus 2, minus 1, this is 0 volt. So this 0, where will it be? So will it actually go like this up?
Yes, sir.
Something like this. This 0 volt is up by 2. This, suppose if this is 10 volt, this is 12. Correct?
Yes, sir.
See now, is this waveform shifted above by 2 volts?
Yes, sir.
Is it opposite to that over here? This was actually lesser by 2 volt. Now it is above by 2 volts. Correct?
Yes, sir.
This will actually go like this. Correct?
Yes, sir.
Okay, let me just do the next one. Let me write. Write the equivalent circuit. Why don't you, Ayush, are you there in a
Yes,
traffic
sir.
place? Your house in near a traffic, near the road, highway?
Yes, sir.
Okay,
Yes,
just
sir.
okay. Maybe you can mute. Okay, somebody else. Okay, where I don't get that noise. It's fine. Sorry for that. Somebody who is whose place is a bit quiet. Shall I pick a student? Let me pick a student. Jannavi. Jannavi. Fine. Jannavi, are you there? Jannavi, are you there? Or someone? Nauda? I want some
Hello.
student.
Yes, sir.
Yeah. What is V0 now? What is V0 now? Is a V0 is equal to what? Shall I say this is equal to
0.
V in R by 2R? Is it
Yes, sir.
V in by 2? Why it is R by 2R? You can see this is the current that is flowing. What is the current that is
Yes,
flowing
sir.
here? Shall I say V0 is equal to I into R?
Yes, sir.
What is I? Is it not V in by 2R?
0. No.
Here,
Yes,
here,
sir.
here, here. This is a current, no? This may not
Yes,
go
sir.
through this, but it will certainly go through this one.
Yes, sir.
Into R, is this R or R will go off? Is it not equal to V in by 2? Provided if
Yes.
these two are same R's.
Yes, sir.
What is V naught? Correct? This is short. The voltage that is measured
Oh,
here is the voltage that is measured here. The voltage that
ground.
is available. The voltage available here is 0.
Yes, sir.
Correct?
Yes, sir.
So, how do we write it now?
For any, okay.
Let me write this.
Cathode is 0, right, sir?
Yeah. No, that's what.
Then
Cathode is
and
0. No, we're not actually finding, okay, when it is on, when it is off, we are not yet gone there. We simply said that, okay, when it is off, what is the thing? When it is on, what is the thing? Correct? Now
yes,
let
sir.
us verify, okay, when it will be off, when it is on. Correct?
Yes, sir.
Okay, now, during positive half cycle, what happens to this? This is at 0.
Yes, sir. It will be in on condition.
During positive, is it on?
Yes, sir.
If it is on, what is the output?
0 itself.
Is it 0?
Yes, sir.
If it is on, what is the output? Okay, sorry, when it will
Half
be
of
off,
the
sorry, when it will be off?
in negative half cycle.
So, when it is off, is the output always half compared to input?
Yes, sir.
Is it exactly the half?
Yes, sir.
Of course, I am not writing to the scale. So, this will be exactly this way and this is just half of it. If this is 10, sorry, if this is minus 10 volt, then this will be minus 5 volt. Correct?
Yes, sir.
Suppose if you make this 10k, if you make this 1k, can you tell me what is this voltage? Of course, if these two are 1k, 1k, if it is 1k, 1k, this would have been minus 10. For minus 10, I would have got minus 5 for 1k, 1k. For 1k, 10k, what will be this expression?
V into 10 by
V
1
naught
plus
is equal to I into R. How much is R? 10k. How much is I
10K.
actually? What is this plus this? 11.
Yes, sir.
Is it 10 by 11 times V in?
Yes, sir.
So it will be almost going in with your input waveform.
Yes, sir.
So what will be this? It is 10 into 10 by 11.
Point.
That will be the amplitude. How much is that? 9 point?
0.9.
Minus 9 point something 9 volt. Correct?
Yes, sir.
Suppose if I reverse it, if I make this 1k, if I make this 10k, what will happen? The same expression.
So 1 by
V
11.
naught will
1 by
be
11. Sir.
1 into
By 11.
V in by 11. So it will be 1 by 11. How much? 1 by 11? Point?
0.09.
0.09. It will be less. Correct?
Oh, just fraction of it, yes, sir.
It will be, of course, 10% of it. Here it will be 90%. Here it is 50%.
Yes, sir.
Correct?
Okay, sir. We can modify the way.
Shape of the waveform.
Length.
Here it is okay going sinusoidal. Here the shape will differ.
Yes, sir.
Correct? This is how this will going to play a role.
Yes, sir. An additional resistance.
Yeah. Let me just do for this. Okay, now hmm. Shall we write the equivalent circuit?
Yes, sir.
So what are the equivalent circuit? Of course, the simplest part is what are the equivalent circuit. So simply short it.
For off condition. Yes, sir. On condition.
This is when it is on. Oh, all the pens are drying out. When the diode is on, so this is when it is on. When the diode is off, this is R, 2 volt, R, V in, V naught. Correct? This is when
Yes,
D
sir.
is off. Okay?
Yes, sir. In off condition, V0 is 0.
Hey, this is V naught. What is V naught here? No current. No current, no
Yes, sir.
drop.
0.
That means
V in itself, sorry.
so V naught is equal to V in.
V
What
in.
is V naught here?
2 volts, sir.
Just 2 volts. This 2 volt plus this drop.
The drop is.
So is it not 2 volt,
Plus I into R.
2 volt plus the drop?
Yes, sir.
So what is the drop due to that?
V in by R into R.
Is it like okay V in into R by 2R?
Yes, sir.
Is it okay 2 volt plus V in by 2?
Yes, sir.
Along with the input voltage, along with the reference voltage, half of the input is also coming up.
Yes, sir.
So let us try to see how the waveform looks like. If this is my input waveform, shall I write this as my reference point?
Yes, sir.
Now,
But it will be, sir, cathode voltage will be greater than 2 volt, right?
where?
Oh, sorry, greater, sir, exact 2 volt.
Here. No. At this
Yes,
point,
sir.
to turn on this, whenever it is off, it is 2, no?
Yes, sir.
So when does this will turn on? Whenever it is because when it is off, this voltage is also 0. There is no
Yes,
drop
sir.
here. So if this has to turn on from this point, if it has to turn on means okay, if the voltage is more than 2, then it turns on. The other
Yes, sir.
half, one half of it is here, the other half will be here. Other half of your input voltage.
Yes, sir.
So this is V in by 2. Where does the another V in by 2 will be there? It will be over here. So
Yes, sir.
anything more
Drop.
than 2 volt is the diode on there.
Yes, sir.
Shall I write this is the transition points?
Yes, sir.
So here shall I say this is now off, this is
Yes,
on,
sir. On, off,
this
on.
is off and on. When it is
Yes, sir.
off,
It follows the vapor.
perfect.
Yes, sir.
When it is on,
It along with the
along with this DC
half of the
voltage,
yes,
half of this will be get added. Meaning
yes, sir. 2 plus half of this,
that's
right,
what
sir?
2 is already there.
Yes, sir. Half
2
of
is
this
already
voltage.
there plus half. You can see whatever shape I am writing is half of that, half of the input.
Yes, sir.
because you are already there at 2, no? This is already
Yes,
2
sir.
volts. So on top of that, you are putting half of it.
Yes, sir.
So over here, same thing.
The same thing.
Done?
Yes, sir.
Okay. So these are different types of waveforms. Okay, let us just move on to how do we write this transfer characteristics. So let me just show you what do you mean by transfer characteristics, or shall we just go for a simulation of all these things before I go to transfer okay, let me just tell you the transfer characteristics also, and then I can go to that there directly. Suppose if I take the first circuit, okay, maybe let me just write it then and there itself so that you can able to comfortably see it. Okay, now what I'll do is I will write a transfer characteristics. For writing the transfer characteristics, let me take a different page and then try to, sorry. For this circuit, uh, transfer characteristics is one where you're writing input on x-axis,
And
the
output on Y.
output voltage is on y-axis.
Yes, sir.
Since we know that I'm going to give a sine wave, this is 0. Let us take this as okay plus 10 and this is minus 10. So you can just think of I'm applying a sine wave across this, which is going up to plus 10 here and then minus 10.
So
Correct?
amplitude of
Amplitude of plus 10, amplitude of minus 10 here. Correct? This is the input waveform that I'm applying, which is varying from 0 to plus 10 and minus 10. It is how it is applying. Suppose if there was no wave shaping, does the output would have been the same shape? Because this is output, no?
yes,
This is
sir.
0, this is plus 10, this is minus 10. So what I'll do is I will write the output also reference. This is my output plus 10 minus 10.
Yes, sir.
Okay, this is my minus 10, this is my plus 10. Sorry. Okay, let me write it here. Fine.
Yes, sir.
This is my reference. Now let us assume that I have a transfer characteristics. Okay, now what's happening here? So in this particular case, can you see during positive half cycle, what is this short circuited when during positive half cycle?
Yes, sir.
So shall I say this is positive half cycle? This one? This is anything above
Yes,
0.
sir.
So in this point, is the output equal to input?
Yes, sir.
So shall I just write it on this line itself? Because this is
Yes,
input,
sir.
this is output. As input changes, okay, if the input is 1, output is also 1. If the input is 2, output is also 2. If the input is 3, output is also 3. So is it the joining of these lines will make this form, make this line?
Yes, sir.
How about the output when during negative half
Zero,
cycle?
sir.
Is it 0?
0. Yes, sir.
This is my output 0. This is output 0. So now, is this exactly going this way?
Yes, sir. V follows
V
in
in,
part.
it is just exactly following. Over here it is 0. Shall I say this is the transfer characteristics for a waveform of this type?
Yes, sir. We can.
Now, if I want to write it for this one, okay, this one, how do I write it?
Yes, sir.
What I'll do, I'll take a different sheet. I will again write V in, V naught, V naught. This is plus 10, minus 10. This is plus 10 output, minus 10 output. Correct?
Yes, sir.
What is the reference voltage? 2 volts. It is positive 2 volt. Let me write a 2 volt line here. Correct?
Yes, sir.
Can I write the reference line for my input equal to output?
Yes, sir.
This is a slope of 1. Slope of 1 means V out is equal to V in.
Yes, sir.
Looking at this, when does diode turn on?
For any value greater than 2, sir.
So, is this is the condition where D is on?
Yes, sir.
Is this the condition when D is off?
Yes, sir.
When D is on, what is output voltage? Looking at this,
Just Veen.
when it is on, it is short
2 volt.
circuited. What is that? Is it 2 volt?
Yes, sir.
So anything more than 2 volts is the output is at 2 volt.
Yes, sir. It remains constant.
Correct. See, this is constant.
Yes.
For any voltages like okay 3, 4, 5, 6, 10, so on so, is the output voltage always 2?
Yes, sir.
For input voltages less than 2, this is it okay 1 volt, 0.5 volt, 0 volt, minus 1, minus 3, minus 5, minus 6, minus 10. What is the output voltage?
It follows same
Follows. So
Veen.
follows means okay, it is the input is minus 1, minus 2, minus 3. If it follows means
Yes,
is it on the same line?
Yes, sir. Straight.
This is my transfer.
Same curve.
This line of slope 1 says that output is same as input.
Yes, sir.
This straight line with slope of 0 indicates that output voltage is constant at 2 volt for input voltages beyond 2 volts.
Yes, sir.
Is it true here? See here, any voltages above 2 volt, is it flat?
Yes, sir. Constant.
For any
remains
voltages
same.
less than 2, is it following?
Yes, sir.
Exactly this. Can you see? Suppose if you want to get back that time response, sorry, that waveform, you can write it like this. Sorry, this is my reference. This is my input voltage. If you want to plot it on this output side, this is my reference. Okay. Anything above 2, what is the output voltage?
2 volts, sir. 2
It's
volt.
2 volt. Anything less than 2, it is following.
Follows.
It's following. Can you see? Is it same as this over here?
Yes, sir.
So this is called as transfer
Some characteristics.
characteristics. Shall we do the same thing for the last problem?
Yes, sir. We can.
Let me take one more sheet. This time key will not fall because I have taken out the key. For this one,
For any value greater than 2, we draw.
okay, let me write. This is always necessary that V in, V not have to be written. You are looking at 2 volt reference. Write a dotted line, reference line, so that a slope of 1 is there. This is slope of 1, correct?
Yes, sir.
Next, what is anything more than 2, it will turn on, correct?
Yes, sir.
So now I'll make this. So anything more than 2, what is the output voltage?
It will be 2 plus half of the input volt.
Okay, now this is 2, of course this is 2 plus half of that. So plus half of means slope is half.
Yes, sir.
Is the slope half here? Plus this 2 is already there because it is above 2 now.
Yes, sir.
How about when diode is off? So this is your D on. This is D off. D is off. When D is off, is it simply following?
Yes, sir. You
can see it is not flat, it is flat plus that half of that slope.
Yes, sir.
This can be half, this can be 1 by 11, this can be 10 by 11 depending on what is the value of R1.
The resistance value.
These two values. So it can be closer to this slope, it can be very close to 0. That depends on the values of R1 and R2.
Yes, sir.
Correct? Suppose if I write it as R1 and R2, so what is the slope then? Is the slope equal to R2 by R1 plus R2?
Yes, sir.
Slope. Suppose if I name it as R1 and this is R2, it is R2 by R1 plus R2.
Yes, sir.
Suppose if it is if R1 is equal to 1k, if R2 is equal to 10k, then is the slope 10 by 11?
10 by 11. Yes,
is
sir.
it close to your output voltage here? Sorry, input
yes,
voltage plus 2 volt.
Yes,
if it is 1k and if this is 10k, of course if it is both are 1k, it is half.
Yes, sir.
If this is 1k, that is 10k, then it is 1 by 11.
Nearer to 2.
1 by 11.
Yes, sir.
So then 1 by 11 is okay, almost flat one.
Same.
Almost like 2. Almost like 2. Of course, it will be very close to that. Fine.
sir.
I have maybe another 2 minutes time. Let me just show you one simulation. Okay, may not be, this is a bit complicated one. Let me show you a simple one. Okay, clipping circuit. Okay, I will just remove this.
Sir, it's not visible.
I'll make it visible.
Yes.
Okay, I'll make it. Where is that? F3 connected. Since I can't make this diode voltage as 0, of course, there will be some 0.6, 0.7 volts. So just bear with me that. Now I can say I'm applying 10 volt signal, and I'm doing a dot DC. Okay, let me not dot DC. Let me do a transient response. Make it as a 20 millisecond, 0, 1 micro. Fine. I'm having this. Let me run it. Okay, let me just take out this. This is a older one. Let me just show you this. Let me see the input. Okay, let me just change the color of this to red. See now, the input is red one, the output is green. Here, maybe what I'll do is I'll make this voltage keep changing. What I'll do is, okay, go back here. Instead of having it as 1, let me make it 0 first. Shall I make it 0? And then run. Can you see now this is, okay, let me just put it in different panes so that you can make out more of this. Okay, where is, okay. Oh, let me change this color to, it's green only, no, why it is, right? Why the color is not changing to green?
Yes, sir.
Right?
Okay, remove and add it.
It's also playing. Okay, I will delete this trace. Add traces, the output. Oh, okay. Okay, let me just put this also here. So no, it is not accepting. Okay, then fine. It's better if it is overlapping. Just here, actually the reference voltage is 0. Reference voltage is 0. But can you see what the output voltage? Output voltage would have been 0 here. See here, this is actually 0. This is not 0 when diode is on because diode is not ideal. So when the diode is not ideal, the voltage that is across diode is now 0.7.
Yes, sir.
That is what is being displayed here. Correct?
Yes,
suppose if I add 1 volt here, if I make it 1 volt, what will be this voltage? 1.7.
1.7.
See there, is it 1.7?
Yes, sir, approximately.
Can you see it's almost there, 1.7. Now, suppose if I, okay, let me just change this, let me take out this, 1 second. It is blinking there. Hey. Okay. This is 1.7. Suppose if I make it minus 1 volt,
It will be 0.3, sir.
it will be minus 0.3.
No, it's minus.
Minus 1 plus 0.7 will be minus 0.3.
Minus 0.3.
Can you see here minus 0.3 here?
Yes, sir.
It would have been minus 1. It would have been minus 1. But you have a 0.7 here. So that minus 1 plus 0.7 happens to be minus 0.3.
Yes, sir.
Correct? Now let us see the transfer characteristics. How do I see the transfer characteristics? Instead of dot tran, I'll go for dot DC. I'll sweep it. I'll sweep it and I will run now. Can you see now?
Yes, sir, seeing that.
This is the reference. Reference is input because you have input over here, input here also. And this is your voltage. This is your output voltage. Can you see the output voltage is following for negative voltages? And of course, till because you have a reference voltage of minus 1 till minus 0.3 it is following. Afterwards it is minus 0.3. This is as per this circuit. This is as per this circuit. Correct?
Yes, sir.
Now I can make this a step voltage. So what I'll do is, I can also do
Change it
something
into
like
step.
this. I can make this a parameter, not this one. Okay, this is I'm changing. So I can make this also variable. Okay, that I'll just show you some other time. So that I can vary. So let us see if I put a resistor, what happens. So shall we put a resistor?
Yes, sir.
That another half of that.
Yes, sir.
Okay. I will make this bold. F7. Take this, put it here, then make it equal to 1k. I will run it now.
It will be half.
Can you see the slope is half?
Yes, sir.
Would you like to see the waveform also?
Yes, sir.
Change this to transient, do it there, run.
And
Can you see, instead of this being flat, can you see this is half of that?
yes, sir.
This is the shape. Here it is exactly following, overlapping, but here it is half of it. Whatever is the voltage, it is half of it, because resistance are same. Suppose if I make this 10k,
It will be
10 by
10
11
by
times,
11.
almost 90% of it. Run it. You can see it's going closer to it.
Yes, sir.
And then if you make this 1k, or if you make this 100k,
0.09 now.
it's almost
1
flat.
by 10%.
It's almost around 2 volts or whatever the reference voltage. See this?
Yes, sir.
Because this is around that reference voltage. Since the reference voltage is 1 volt, it's around -3. You make it around minus, how much you want? Let me make it 3 volt. So it's above 3.7, it will be there. Can you see it's above 3.7? This reference will be 3.7. See here?
Yes. 3.5 something.
Almost there. You can see 3.5
Yes, sir.
plus 10%
That
of that amplitude.
Yes, sir.
3.7 plus 50% of this if the input is, sorry, if the resistors are same.
Same. It's equal.
Okay, where is that? I'll make the resistance the same. You can see, okay, same means I should make it 100k.
1K.
No, this is 100k. I should make it 100k. Can you see now? Is it exactly half of it? So it
Yes.
is 3.7 plus half of 5. Half of 10 is 5. That it should be 8.7. You can just go on there and then see top. Is it 8.7? So it's not 8.7. Sorry, how much is that?
Sir, 5 plus this one. Like,
Okay. How much is 5 plus? How much is my reference voltage? Let me just see.
reference is 3.
3. Okay, 3 plus half of it.
Half of the remaining portion, right? So 7 by 2, I think.
Yeah. So let me just check it out. How much is this? This is 3. This is 100k. Yeah, we can just verify with that voltages. So I think I'm just taking somebody's time. So sorry for that. Let me just stop now.